Thought Leaders, a closer look for the curious.
Hello and welcome to another episode of Thought Leaders. And joining me today is Dr. John Cassala.
Pleasure to be with you.
John, you're very welcome. Tell us, how did you get involved in such a, what people regard as very grim and gruesome career?
It's a very interesting question, and the short answer would be it evolved naturally from my experience working in biomedical sciences and working in various projects in the London hospitals in skin diseases and bone conditions and so on. And then moving into teaching anatomy, physiology, pathology, and then finally into the forensic science degrees when they became the new, if I may use the expression, sexy subject to deliver science to students in bite-sized chunks in ways they would understand as applied science. And because of my interest in working in hospital medicine and pathology, the natural evolution into the world of looking at illness and pathology and then death led me down this road. And there's an interesting story of a colleague of mine at Keele University who started around the same time I did at Staffordshire University, which is only about 18 miles down the road in the United Kingdom. And he said, look, I'm doing this project. We want to do some geophysics. We want to look for missing things, be they bodies or be they caches of weapons or money or drugs. Are you interested in coming to work with us collaboratively? And I said, well, I'll do anything for a cup of tea. So we started talking, and then Dr. Jamie Pringle and I began that research project together looking for clandestine burials.
Okay, and what does that actually mean?
Well, if we go back a step, if you look at the Office of National Statistics in the United Kingdom, and statistics always lag behind real time, so we're talking of a few years ago, there were 25,000 people went missing in 2015. And now a lot of them go missing for various reasons, but a percentage of those 25,000, and this is just the United Kingdom, remember, so if you scale it up to America and to Europe, it's much bigger numbers. A lot of those people are considered to have been perhaps murdered and dispatched and buried. Now that's either in the ground, so terrestrial burials, or in water, so they've been weighed down and submerged, or there's a whole other range of more gruesome ways you can dispose of human tissue. But fundamentally, it was about trying to understand where those individuals may have gone so that when a police inquiry is initiated following a missing persons investigation, could we start to help the police by offering them tools in a toolkit, scientific toolkit, of how you would try to find someone and do it quickly and do it cheaply, because at the end of the day, police services work on a public purse, and time and money are important to them, but also efficiently to be able to include an area for investigation that might be the size of a football pitch or the size of a small county, and it can be terrestrial or it can be water.
Okay, and do you know what's the most common method of disposing of a body? Is there a difference between the panic and the planned?
It's a really interesting question, and for most of the scenarios we think about, we would consider that it's, forgive the expression, the oh shit moment. There's been an incident, the red mist has come up, you're looking at a fight, somebody's killed somebody, and then they think, how can I get rid of them? And we've gone through these scenarios, academically speaking, many, many times. And the first thing you would try and do is you hide what you've done. So you wrap them up in a blanket or a sheet or a duvet. You try to cut them up using household implements. If you start to find people who've been using more elaborate techniques, such as they've gone out and bought plastic sheeting and gaffer tape, it suggests premeditation. If you see that they've gone out and bought themselves an axe or some kind of chainsaw, suggests premeditation. Because at the end of the day, we want to help the police identify, was it genuinely a manslaughter? Oops, it happened, but it happened, and then they were stupid afterwards and didn't call the police and admit to it, then tried to hide it. Or was it genuinely premeditated malice aforethought to murder and dispose of someone for whatever reason?
Okay, and is there a profile, a specific profile of someone who commits these kind of crimes?
Look in the mirror is what I always say to people who ask me that question. And if you want to know the profile of a potential murderer, well then just look in the mirror, because we all have that capacity within us. It all comes down to anger, emotion, that red mist we talk about. The premeditation suggests, and I'm not a criminologist and I don't have any experience in terms of forensic mental health, but the premeditation suggests a callousness that I'm glad to say I can't truly understand, because to take another life is much more than just disposing of the human material that's left behind. It's the callous decision to change the life of that individual permanently, but also the wave it sends out of their friends, their family, their social groups, etc. So you kill one person. There's the old expression they say, if you dig one grave, dig two, because you affect yourself. And of course you affect the family and friends of that person that you've killed.
Okay. And you said about the 25,000, which is a phenomenal number every year for the police to deal with, of missing persons. Now, the vast majority I would take would be found within 24, 48 hours or turn up again. But there is a section of that never be found or take longer to find. When do the forensic scientists usually step in?
What would happen is that family friend or a member of the family would report it to the police that they're concerned that somebody was expected at a certain place, a certain time, didn't show up for work, didn't show up at home or whatever, and has been gone for a period of time. And that period of time varies from country to country and legal environment. But usually after about 24 hours, you'd start to worry. As a parent, I can say after about 20 minutes, you start to worry, but certainly after 24 hours. So then the police would become involved and they would do all the usual checks. Then if there was a serious concern about the risk to that person, particularly if they were elderly or they were juveniles, because those are particularly vulnerable groups, you would have a massive manhunt set up with the police service. The scientists wouldn't get involved necessarily until there was a suggestion of a body or body parts or suggestion of the body having been present, because of course bodies are buried or dumped and then somebody comes back a short time later and then moves them to what they call a secondary deposition site. So any of those things would kick off the scientific groups being involved. And I worked with Her Majesty's Government, was called an organisation called CAST, the Centre for Applied Science and Technology. And they set up a group, for want of a better word, of anoraks, those of us who had special interest and skills in either geophysics or body location or victim recovery, dog detection or whatever the skill set, soil forensics, to see if we could come up with the latest and newest techniques to help the police find a body. Because of course what you see on the news are usually police officers or police search groups on their hands and knees firking around in the grass or sticking bits of metal rod into the ground to see if they can find anything. And that's what the newspapers pick up. But what we're talking about are looking at more elegant techniques such as geophysics, things you see on those TV programs like Time Team, or these days using drones to go up in the air and capture large areas using some very exciting kit that can pick up changes to the environment, to the scenery, but also in my kind of research, which is looking at chemical changes in the soil that might suggest, say in a football pitch, you took 4 or 5 samples around, some with the goal, midfield, some in the corners, and you might look for chemicals that suggest a body was decomposing a few feet underground, or not. If not, then move on, find somewhere else to go and investigate.
Yeah. And you mentioned that technology. Is there something really exciting coming out now, or has come out in recent years, that has changed the game of forensic science?
Certainly. I mean, as a scientist, I'd say all the technology is exciting, but your point is a good one, which is what would hit the 10 o'clock news as new, exciting technology, and that would be, I would suggest the use of drones, because they can go to places where we can't easily get to. You wouldn't be able to afford or necessarily want a helicopter to be going up there because a whole range of reasons, cost, but also the down thrust from the rotors. So drones and what you can add to those drones. And one of the newest techniques coming out is one called hyperspectral imaging. Now, it's been used by the farming community for a long time, and they can send a drone up with a hyperspectral camera and it can look at crops, it can look for pests within those crops, it can look for soil changes which those crops are growing on. And then, of course, the forensic scientists realised, well, this might be interesting to look for clandestine burials. And can you see where a grave has been dug? Well, with respect, when you dig a grave, you dig out some earth, you stick a body in it, you fill it in. And have you noticed you always find that there's always more soil that comes out than goes back in again, so it's never flat. So with respect, any police officer from 100 yards should be able to see a freshly dug grave. But what I'm talking about is 1 year, 2 years, 10 years, or 20 years later, when you would not be able to see in the ground visually a change, but hyperspectral imaging or thermal imaging cameras, or other technologies such as ground penetrating radar would suggest that's an area of interest for the senior investigating officer and his team to look at more closely.
Okay. And within your experience, what is the hardest case to solve when a body is found in water or shallow grave or burned? Which is the worst kind of scenario to kind of for forensic scientists to get down, digging down into?
The hardest case to solve is where you have a suggestion in a police investigation of a murder, but you have no body. And more I've noticed the last few years of no body murders, as they're called, where individuals may have been indicted on a murder charge and yet there is no body to find, and there becomes a race and a pressure to identify the presence of a body or body parts or what we call anamnestic material. It might be something like a ring or a piece of a watch or anything that was physical that was associated with that individual. And certainly recently I was involved in a case where a young lady went missing. 2 individuals were indicted on that murder charge, but they couldn't find the young lady. The individual suggested she'd gone off to the circus or something equally absurd. And although there was some suggestion of geophysical change in the garden, and although there was a suggestion of some chemical changes in the garden that could have been human, the one thing we always must remember is until the science has been proven and proven and proven again, you always err on the side of caution, because if you start to go into a witness box and you say, oh, well, you know, I've done this research for a few years, I can see that there was probably a body there, and these people are found guilty when they're actually innocent, that would be a terrible miscarriage of justice. So we're always very cautious. And I'm delighted to say I'm in at the birth of a new science. You know, chemistry and physics and mathematics and biology are hundreds, if not thousands of years old. But this area of what we call thanatochemistry, the chemistry of death, is a new and evolving science. And when you add that to the wider elements of techniques like hyperspectral imaging or ground penetrating radar, it's all very exciting, academically speaking. But equally, I find it exciting because I think we can contribute to help the police and society identify a body, find a body, and then repatriate that person's body to their family, but then also help a police inquiry move forward robustly, because that's what we want. We want to help the courts. Is that person standing in the dock? Well, they are innocent until they're proven otherwise. But are they truly innocent? And can we help the judge and jury come to that decision or not?
And one of the advances in science is research, and you've been campaigning for some time for what is called a body farm. Can you tell us a bit about that, and what are the benefits of this research?
It's a body farm is a term that was coined back in the 70s when Dr. William Bass was asked questions by local law enforcement in the United States. They had a series of questions that they needed answering for the courts. And Bill Bass realised the best way to do that as a scientist was to experiment. And so he began his experiments, and he began working in what they call Death's Acre. It was 1 acre of land they let him have in Tennessee near the university. And he began conducting very sensitive, very ethically and morally driven questions on human remains to try and help answer those questions. So that was for forensic perspective. Since then, in the United States now, there are something like 8 facilities. I prefer the term taphonomy, and taphonomy means the post-mortem fate of human remains. So we call them taphonomy facilities rather than body farms, but with respect, the press call them body farms. And so the idea is that a very gracious donation of somebody who has died and doesn't want their body to be just buried or cremated or whatever, and says you can conduct research on me. Those bodies are used to identify questions such as time of death, place of death. How do they decompose and change? Because we're all fundamentally made of exactly the same materials, proteins, carbohydrates, fats, etc. And we change in very specific ways. Now, knowing that, we can help answer those questions about time and place. As they say in forensics, the who, what, why, where, how, and when. And those are the kinds of experiments that are conducted in these facilities. Now, there hasn't been one in Europe. There was one in Australia. And then about 3 years ago, despite my arguing for one for over 16 years in the United Kingdom, we were not the first to have one in Europe. Colleagues at the Academic Medical Centre in Amsterdam were the first to create a facility, and well done to them. And I've been collaborating with them, and some very gracious donations of bodies from some of their patients have allowed us to look at how their bodies decompose. And we've had some amazing findings very early on in terms of the delay of decomposition in the soil in Amsterdam, which is very sandy, in comparison to, say, the soil here in Sligo, which is very clay-like, which is very similar to the United Kingdom soil, very heavy, muddy, clay-like soil, where decomposition occurs much more rapidly. So we know that if you bury somebody here in Sligo compared to if you bury somebody there in Amsterdam, rate of decomposition, despite the fact they died on the same day, they were buried in exactly the same way, would be very different. Now, these might seem like very simple questions, but those answers were not available to the courts a few years ago.
So what you're saying is if somebody buried in a clay field 100 yards away from someone buried in a sand dune,
Very much.
and they could be buried on the exact same day,
Yeah.
but they could seem like they're months apart or weeks apart at least.
Absolutely. And of course, one of the key questions is when did that person die? And there's the old story of, well, when were they last seen alive by somebody you can trust, and when were they found dead? Now, if that timeline is a week, it's within a week. But if it's within 10 years, then how do you find out when that was? And so understanding the science of how our bodies break down, those Lego bricks become deconstructed, helps us answer that question. Because if we know it was at least 5 years ago, that can help corroborate or not a witness statement.
Okay. So with all that in mind, how does somebody get into a career of forensics?
The same way I would suggest anybody who's fascinated in chemistry, physics, biology or maths does, which is that you study the sciences at whatever level in school. You then enter a degree at a university, and you don't have to study for a forensic science degree. I've always argued that forensic science is nothing more than good science that's applied to the law. So you would study for a degree. You can study for a forensic science degree if you wish, and then it's about following your passion and finding out who is conducting the research around the world. I have to say, there's not a lot of us. We're in the hundreds. Possibly you might hit 1,000 if you looked on a planet of, 8 billion, but that's not a lot. So we all know each other and we all collaborate terribly well, although we're in competitive environments for research funding and within different universities. So we all work together. So that would be the career aspiration if you wanted to. But I think it's important to understand that all of us are very well grounded and sensible individuals who are asking fundamentally important scientific questions to help a judge and jury. And I always remember the families of those missing persons to find them and repatriate them. And it's not just about the crime. It can be a humanitarian reason, it can be an environmental reason. So it might be that somebody's gone missing in, say, a tsunami or an earthquake, or a building has collapsed, etc., etc. So it's about using those technologies to help find those persons as well.
Yeah. You've recently come to Ireland, and can I ask you, like, from your initial view of Irish policing forensics, are there areas that the country could massively improve on?
I would always argue that the police service of any country that I'm working in is superb. I think the important thing is that science can help police investigations when it's needed and when it's asked for. It's not going to replace police investigations because fundamentally it's about coppers asking the right questions of the right people. But we are some of those right people. And if they need a question answering, such as, is it likely that there's a body in that lock over there? What would you do? Well, you can send in divers and spend an awful lot of time, an awful lot of money. Or you could do something like put ground penetrating radar onto a boat and put the boat on the water, because the ground penetrating radar doesn't know it's on water, it just knows it's going through a certain medium. Or you can use sonar, or you can use your hyperspectral imaging, or you can take water samples in my research, the chemical research, to look for elements of human material in there. So it's about saying to the police services, Science is evolving. Our understanding of how to look at human beings as a holistic creature that breaks down into these Lego bricks is evolving. We can help you find the smallest fingernail or the largest part of a body, or indeed the whole person.
Yeah, it's fascinating, and it's really interesting to speak with you today. Finally, have you any research that's coming up now that you're working on at the moment you'd like to share, or at the initial stages of just settling in? Just like
No, absolutely. I've always argued that one of the things that we as scientists must do is to tell the public, the taxpayer, the purse holder of any funding that you get, what we do. And it's incumbent upon us to share science, especially in an area where people don't want to talk about death, for example. So I'm always happy to talk about it. In terms of the research, the work in Amsterdam, some fascinating experiments which demonstrate the retardation, the slowing of decomposition in different soils. That really wasn't appreciated. But also one of the other elements is the chemical detection of a human body or parts of a human body. And there are some very clever electrochemical sensors being developed by a colleague of mine at a university, at Lincoln University. And working with him, what we'd like to do is to create very simple test kits that would allow police officers or basically trained individuals to go out into a field, take a soil sample, for example, shake it up in a test tube, and if you get a reaction that says, yeah, this is suggestive that there might be a body in this field, then it would help the police to include or to exclude that in that area of inquiry. That's what I'd love to be able to do in the next few years up to retirement.
great, fantastic. And final question is, for initial thoughts of Sligo, the campus here, and also we're becoming the Atlantic Technological University. Any thoughts on that, or what we can look forward coming from university? What can we look forward to in that kind of sense?
Well, one word, wow. What can you say? I mean, the birth of a university, IT Sligo is an amazing facility and will always be IT Sligo, but is now evolving into a university with everything that it brings with it. So the opportunities for networking with colleagues out here, for expansion of research opportunities, for our students to become involved in some of the research, for example, that I'm doing, which they are. I'm involving some final year student projects in some very basic elements of that research, but it's all to play for. I mean, it's a wonderful world of opportunity. Universities are melting pots of innovation, entrepreneurship and enthusiasm.
Fantastic, John. Thank you for joining us. It's been an absolute pleasure. And
Thank you.
We'll have you back again, no doubt. Thank you.
Thought Leaders, a closer look for the curious.